Today, we are answering the world's weirdest, most fascinating questions from you, our curious viewers. Because here at Kurzgesagt, we believe there's no such thing as a dumb question, only amazing ones disguised as absurdity. So let's dive in, scientifically and seriously, into two delightfully ridiculous questions that just might break your brain. Question 1. How many jellyfish do you need to power Tokyo? Tokyo, one of the world's most electrified cities, devours about 280 terawatt-hours of electricity per year. That's more energy than Australia consumes, and more than 20 other countries combined. Could we power it with jellyfish? Some species, like the Achoria victoria, glow in the dark thanks to fluorescent proteins. Place one of them in front of a solar panel and, voila! You get about a microwatt-hour of electricity. To match Tokyo's yearly appetite, you'd need 1.3 quintillion glowing jellyfish. Yeah, that's a lot of jelly. So, what if we go bigger? Meet Nomura's jellyfish. These oceanic giants are up to 2 meters wide, weigh as much as a grand piano, and are armed with 1.000 tentacles, each stretching up to 4 meters. Recently, their population has exploded, and not in a good way. They're wreaking havoc on ecosystems. But maybe, just maybe, we can give them a job. Do jellyfish produce electricity? Well, kind of. Actually, no. That electric jolt you feel when one stings you? It's not electricity. It's venom, injected by microscopic dart guns called nematocysts. So how can we really get energy from them? Piezoelectricity, the squeeze of power. Here's the plan. Let's wrap each tentacle of our giant jelly in a custom wetsuit made from a piezoelectric material, like nylon 11.11. As the tentacles move, they bend the nanofibers in the suit, generating a small electric charge, just like quartz in a watch. Sounds neat? The result? One Nomura jellyfish generates 1 watt. 1 single watt. That's about 10 kilowatt-hours per year, or enough to run your laptop for 20 days. Powering a megacity? You'll need 29 billion jellies. That's right, to power all of Tokyo, you'd need nearly 29 billion Nomura jellyfish. For comparison, there are 27 billion chickens alive today. So the scale isn't impossible, just absurd. If each jelly gets a 5-meter cube to swim in, the entire jelly farm would be 7 times the volume of Mount Fuji. Then there's the wiring. Each jelly needs to be connected by cables, insulated to avoid short circuits from the wiggling arms of their neighbors. Even if we somehow pull this off, there's one small problem. They die a lot. Maintaining this living power plant would be like spending $1 million to get one. Just $1. So, is it a good idea? Absolutely not. But hey, we did do the math. Question 2. What if it rained bananas for a whole day? Let's turn the sky into a fruit salad. Imagine that for one full day. Every drop of rain is replaced with bananas. Let's break this down. 1 square meter of land can receive millions of raindrops during a storm. If each of those becomes a banana, we're no longer talking about fruit, we're talking about planetary destruction. That's too much, even for our imagination. So let's scale it more reasonably. Take the average daily rainfall across Earth, about 1.33 trillion tons of water, and convert all of that into bananas. Each banana weighs roughly 120 grams. So we end up with a whopping 11.1 quadrillion bananas. Falling from the sky. Bananas from the sky, a fruity catastrophe. In this bizarre new world, even deserts get drenched. The Sahara alone would be buried under 15 trillion bananas. The caloric value? With just this one banana day, we'd have enough food to feed all of humanity for over 100 years. Sounds great? Not really. Let's talk physics. Bananas falling from 3.000 meters, the height of mid-altitude clouds, would hit the ground at 240 meters per second. That's the same energy as dropping a bowling ball from a 50-meter building per banana. Multiply that by 11 quadrillion and you've got apocalypse fruit. London. Banana ground zero. One of the world's rainiest cities would receive 21 billion bananas. Roofs collapse. Windows shatter. Landmarks are pulverized. Streets are blanketed in banana pulp. People? Toast. The world drowns in a rotting banana smoothie. Worse still, as bananas decompose, They release methane. In this case, 160 billion tons of it, 280 times the annual methane emissions of our entire planet. Methane traps 28 times more heat than carbon dioxide. The result? A sudden, uncontrollable rise in global temperatures. Ecosystems collapse, species vanish, Earth spirals into a full-blown mass extinction event. Conclusion: asking wild questions is worth it. So, can we power Tokyo with jellyfish? No. Can banana rain feed the world? Yes, and destroy it. But what both of these questions remind us is, curiosity is powerful. Even the most absurd "what if" can teach us something real. So keep those crazy questions coming. Because at the end of the day, wondering wildly is the first step to understanding deeply. If you want this turned into a narration-ready script with speaker cues or adjusted for a specific voice actor style, e.g. dramatic, quirky, scientific, just let me know.